Hello students, welcome to the lecture on commercial ERP package description, and after the lecture we will be able to learn the following objectives. Explain the commercial ERP package description, discuss the Ramco Marshall, describe the Oracle application, explain the client or server architecture, discuss the open source ERP. The commercial ERP is an expensive package and suitable only for bigger corporations. The prices do vary significantly, but according to the size of the company and volume of business. In any cases, they have been found to be extremely costly irrespective of the quantum in which they are purchased. These packages are not subject to flexibility and molding. The usage modalities are rarely liberal and cause troubles when they are modified. Hence, the deployments also turn out to be costly and inconvenient due to the procedure involved in the future. Another major allegation against the package is that they consist of a lot of hidden costs. When one compares commercial and open source ERP, commercial systems are not flexible in nature. They let business with no other choice but to change the way of business. However, when it comes to open source ERP, everything was decided by the code. Therefore, companies can do the necessary modification in code and without much support from the vendor. Another advantage of open source is that it does not interfere with the regular schedule of the company during the implementation stage. When one studies commercial and open source ERP, the time allotted for implementing open source ERP is very less when compared with commercial ERP. The innumerable number of complexions in commercial ERP calls for longer time span. It consumes a lot of time not only during implementation but in every stage of ERP process due to the nature of work involved. When it comes to the question of relying on the vendor, the open source ERP owners enjoys a considerable edge than the commercial ERP. Since open source are license-free users having full freedom for taking care of needs by themselves. The productivity is also high in open source ERP system and the failure rates are very low. Lots of training is required for using commercial ERP. It calls for lots of investment in terms of time and money. If they do not give the necessary impetus, the result will be poor. Similarly, validity of training sessions designed and handled exclusively by the ERP vendor is also debatable. On the other hand, open source ERP does not require much training. On comparing commercial and open source ERP application, commercial ERP systems are less secure. They are by and large prone to the traps and pitfalls of hackers. Even though open source ERP makes everything transparent and available in the public domain, it brings into the notice of user whenever something goes wrong. Few end users change the underlying code of an open source application, but when the need arises, open source provides access to the code to make changes to suit each distributor's unique business needs. Open source customers enjoy a refreshing level of transparency from their vendors around activities such as bug reporting and fixing and roadmap planning. ERP solutions touch every aspect of a company, from warehousing to accounting. As such, a company's ERP solution should easily integrate with existing IT infrastructure components such as application service, directory services, and storage arrays. Open source solutions are compatible via standard-based interfaces with multiple technologies, including support for lowest cost commodity operating system, databases, utilities, and hardware. Let us now study next topic, commercial ERP package description. Commercial ERP solution, rather than go with open source ERP solutions, stack up against a commercial ERP counterparts. The time to market or the time it takes to implement a commercial ERP package is generally longer. Typically, organizational processes need to conform to the software process itself, and effecting that change can take a long time. Training and ramp up commercial ERPs. It typically need specific training for the developers or implementers, example SAP, Oracle ERP, etc. But for open source, one has the entire source code itself. Open source ERP providers believe that there is no better documentation than the source code itself. Source code may be the best piece of documentation for a developer, but for an end user, it usually means nothing. Support. There is a plenty of software professional service firms who are willing to support a SAP or Oracle implementation. The ecosystem is established and not only generates revenue for these implementation firms, but also delivers client value that is proven. It is not true that one will rarely get a vendor to support an open source ERP solution other than the solution provider themselves. If one is not sure that one can rely on a vendor or one's own capabilities to support the current system, it might not be a good idea to invest in an open source ERP, even if it is a fraction of cost today. Companies like SAP and Oracle have been in the ERP business far too long for anyone to have doubts about their implementation track record. Open source ERPs are relatively new and do not have too many implementations to boast of. Many large clients of enterprise commercial software are themselves not in the business of writing and maintaining software. They would rather rely on specialists and license the relevant technology from them. For successful integration of ERP into customer business, ERP should match the customer business model. Therefore, actual customization of the core ERP to the business model is essential. Changing commercial ERP to fit the business process will require plenty of consulting money, sophisticated IT staff, as well as time to develop customization. Industry leaders like SAP promote their best practices and processes. Therefore, what usually happens is that business has to change to fit the ERP best practices and not the other way around. Adapting to the best practices could be a difficult as well as time-taking task for many organizations. Implementing commercial ERP takes a long time. In fact, even 6 months are considered to be short period for implementing commercial ERP. Also, in case of commercial ERP, the way business is done and the way people do their job needs to be drastically changed, and this may take lots of time before ERP shows its payback potential. Ramco Marshall has been developed with an understanding of the forces of change in the business world. Supply chain requirements and customer support issues force many companies to operate from multiple locations and with multiple currencies and multiple languages. Organizational growth and diversity cause businesses to require a broad range of application and features. Continual business process re-engineering is necessary to stay competitive. To respond to forces such as these, Ramco Marshall provides a unique approach featuring distributed computing, breadth of application, and flexibility. Ramco ERP on cloud is the most preferred choice for businesses across the globe as it encompasses inbuilt intelligence and business acumen for the industry. Ramco ERP on cloud covers the entire spectrum of enterprise function through a suite of products, manufacturing, financial management, supply chain management, SCM, human capital management, HCM, customer relation management, CRM, enterprise asset management, EAM, project management, process control, analytics, advanced planning and optimization, and connectors. One can decide which solution one wants to use, scale up and add more solutions as the business grows. Marshall divides the processing load between the client and the server. Application logic that does not require any external data, the graphical user interface, are placed on the client. Application logic that requires access to external data resides on the server. Overall, Marshall allocates about half of the computing load to the server, which minimizes network traffic. Marshall consists of 35 applications in 9 functional areas: process production, discrete production, sales, treasury, financials, human resources, logistic, plant maintenance, and statistical process and quality control. Marshall also includes security features and various productivity tools such as an application configurer, Duped, a data drill down tool, the workflow engine, and the report writer. Each of Ramco Marshall application modules are capable of working alone or with other Marshall or third-party application in any configuration in order to meet specific business needs. Marshall is fully scalable, allowing the addition or subtraction of user, functions, application, servers or locations with minimal effort. Marshall's tools and utilities facilitate customization on every level, from the entire user interface to individual data fields for a single user, an entire organization, or any number in between. In addition, Marshall was created using industry standard tools, Visual C++ for Microsoft Windows NT and SQL Server, to simplify future addition to or modification of the source code. An Oracle application is ERP software. Oracle applications are one of the enterprise resource planning business application packages. It comprises of various modules, libraries, forms, reports, etc. Oracle applications are designed on the basis of generally acceptable accounting principle, GAAP. It is used to channel the business needs of an organization. Enterprise resource. Planning software is a business management software application that allows an organization to use a system of integrated application to manage the business. ERP software integrates all facets of an operation, including financing, distribution, accounting, inventory management, sales, marketing, planning, human resources, manufacturing, and other operating units. The increasing use of computer in daily business activities has increased the importance of ERP solution for organizations of every size. Today, one can see companies using different kinds of software in every department. These softwares cannot interact with each other, resulting in decreased productivity. The primary goal of ERP software is to integrate data and processes from all areas of an organization and integrate it to ease access and make the workflow more efficient. ERP software does away with need of using different systems in an organization and present business leaders with data that is useful to make insightful decisions.
Hello, my name is Kevin, and I'm with Oracle Accelerate for Midsize Companies Global Programs. Today I'm going to talk with you about Oracle Business Accelerators, powerful, cloud-based rapid implementation tools developed and maintained by Oracle to get you up and running on a wide range of Oracle software products quickly and reliably. In a nutshell, Oracle Business Accelerators significantly reduce the time between the day you purchase software and the day you start using it. Let's take a look. When it comes to business applications, CFOs and CIOs want to realize the value of their investments as soon as possible. That's why we're committed to getting you up and running quickly. Let's take a look at a typical mid-sized business. We'll pick a manufacturer. With more than 290,000 mid-size Oracle customers, it could be one you know. A deeper look into this business reveals that it has several business functions: the manufacturing operation itself, plus financial management to manage the accounting processes, payables and receivables, sales, purchasing, inventory to ship and receive, order management, and so on. So when our typical business invests in a critical business application, it's buying software that has to manage end-to-end transactions in the most efficient way using best practices. And because mid-sized customers need applications that support growth, they want top-tier software, the same software that the largest companies use to run their businesses. Oh, and an end-to-end transaction? That's a business process that is executed across multiple business functions. Oracle Business Accelerators incorporate proven best practices and are provided through qualified Oracle partners free of charge to help customers, such as you, safely and rapidly deploy Oracle's top-tier applications for fast time to benefit and with less risk. Here's how it works. Oracle Business Accelerators have a set of proven best practices for your selection that is outlined in the form of a set of business processes. Each of these business processes represents an end-to-end transaction across multiple business functions. An example of a common best practice might be the requisition to receipt process, which involves these steps. The requisition is created. The requisition goes through an approval process. Once approved, it goes to someone who can create a purchase order. The purchase order is sent to the supplier. The supplier fulfills the order. Receipt of the order is confirmed. Lastly, payment is issued to the supplier. This flow consists of the following business processes: manage and authorize requisitions, issue, authorize and distribute purchase orders, receive material from supplier, and record received services. And that's just one business process. Each Oracle Business Accelerator delivers a comprehensive set to cover the typical business functions in a mid-size organization. Each of these business processes is clearly illustrated in a flow diagram, a video, and detailed documentation, so you know what the Oracle Business Accelerators deliver out of the box. This is where it gets neat. Oracle Business Accelerators provide a defined scope and automation based on best practices for your industry. And they are so flexible, they can capture and integrate your unique business processes and requirements. With Oracle Business Accelerators, you are not starting from scratch designing business processes that the new software has to support. Best practice business processes are already built in. So, rather than the first step of the implementation project being a lengthy iterative scope definition exercise, with Oracle Business Accelerators, you and your implementation partner will engage in a scope confirmation exercise, allowing you to configure your Oracle applications faster and with more flexibility. Safe, reliable, flexible, fast. The end result? A functional Oracle Applications instance reflecting your unique business requirements in weeks versus months, depending upon complexity. How can we do this so quickly? I'll show you. The Oracle Business Accelerator Configuration Tool generates setup questions specific to your business process. Your implementation partner is then guided through the process of responding with your unique business data and setup requirements. This ensures that the processes are tailored to your specific needs. Said another way, the sophisticated configuration engine asks your implementation partner the right questions in the correct sequence so that you get a safe and reliable configuration. Once you have worked through all the questions, the Oracle Business Accelerator will help you quickly reach the optimal configuration for your enterprise software. The end result for you? Predictable and expedited implementations of proven Oracle enterprise-class applications, so you can focus on growing your business. Oracle Business Accelerators are available for a wide range of Oracle applications. Start working with your Oracle software within weeks, not months, and vastly improve your enterprise software ROI.
Client-server architecture. Architecture of a computer network in which many clients request and receive service from a centralized server. Client computers provide an interface to allow a computer user to request services of the server and to display the result the server returns. Servers wait for requests to arrive from clients and then respond to them. Ideally, a server provides a standardized, transparent interface to clients so that clients need not be aware of the specifics of the system that is providing the service. Today, clients are often situated at workstation or on personal computers, while servers are located elsewhere on the network, usually on more powerful machines. This computing model is especially effective when clients and the server each have distinct tasks that they routinely perform. In hospital data processing, for example, a client computer can be running an application program for entering patient information while the server computer is running another program that manages the database in which the information is permanently stored. Many clients can access the service information simultaneously, and at the same time, a client computer can perform other tasks such as sending email. Because both client and server computers are considered intelligent devices, the client-server model is completely different from the old mainframe model, which utilizes a centralized mainframe computer that performs all the tasks for its associated dumb terminals.
In a client-server relationship, the server controls access to shared services and data. The client sends requests to the server to access those resources. For example, the client sends a login request. The server checks the username and password to see if that request is valid. If it is, then the client can access the network. That doesn't give the client the right to use all the network's resources. For additional requests, such as viewing shared network files, the server checks to see if the client has permission for that specific action. If yes, then the request is granted. If no, the request is denied.
Client-server architecture can be considered as a network environment that exchanges information between a server machine and a client machine. where server has some resources that can be shared by different clients. In a client or server architecture, individual computers are connected to a central computer which is known as server.
What is client-server? A client-server architecture is a network architecture in which each computer or process on the network is either a client or a server. It's simple as that. So they are components of a client-server system. For example, there's a client, a server, and a communication network. So clients are basically applications that run on a computer, rely on the server for files, devices, processing power. Example, email client, an application that enables you to send and receive email. Computers or processors that manage network resources, which are the servers, disk drives, file servers, for example, printers, printer server, network traffic, network servers, and so on. An example of database servers are computer systems that process database queries, like for example, Microsoft SQL Server. Communication networks, in terms of networks, connect clients and server. For example, there's a network here and they're showing you a microwave link together with probably a wired connection here. This could be any wired connection. It could be like a WAN link or something like that, serial cable, or or these could be Ethernet and so on. But the whole idea about communication network, this is the whole thing about distribution, an introduction to what you call distributed computing. So client-server computing, for example, processes take place on the server and on the client. Servers store and protect data, process requests from clients, and clients make requests, format data on the desktop. And this is the whole idea of the client-server system. So there's a process taking place, either on the client or server, then the server stores and protects the data, process requests from clients, and clients make requests, format data on the desktop, and so on. Right. Application functions, for example, there is software application functions are separated into three distinct parts. So there's a client for presentation and application logic, which we're going to look at some other time. Then there are data management, where the server is consistent. So we have presentation and application logic and data management as the three distinct parts. So here we look at it here. The data management, which is the two client types, fat clients and thin clients on the presentation level. This is one. Three logical ties, which we're going to talk about a lot more. Application logic, which will brings us to the fat client, and data management, two client types in terms of a three logical ties. Because there's both three tie and two tie system. Database application most commonly used on client server architecture. Now before we talk about middleware, I'm gonna play two videos for you all afterwards, so you're gonna look at it from one that deals with file server based systems and the other one that deals with application services in terms of client server architecture, which is really the true architecture that I always like to make reference to. So we're gonna look at these tapes, and these tapes will be down there for you all to look at. I shouldn't say down there, but like uploaded on Moodle, so you all could take a look at it. Most importantly, I want to introduce you all to something what is called middleware. Software that connects two otherwise separate applications, which is true. Example of middleware products is link a database system to a web server, because I mean, we would want to have some sort of communication link. And I don't want you all to look at it as a protocol, but you could look at it as an analogy. An analogy, you understand? But middleware is basically very simple. Software that connects two otherwise separate applications. And I want you all to go and do some research on middleware and present it to me in class next time that we meet. Right, so types of servers, for example, they are application servers, they are audio video servers. Yes, they are, like for example, those who are streaming video for us to take a look at, and audio. YouTube, they are chat servers, like a lot of you all who love to chat. For example, Facebook have a built-in chat program, Microsoft MSN messengers. They are fax servers, FTP servers, which you all have to set up a FTP service for me. We're going to talk about groupware, very, very, very brilliant. Internet relay chat servers as IRC as well. Then list servers, mail servers, news servers, proxy servers, telnet servers, web servers, and Z39.50, which I would want you all to find out more about these different types of servers, the A to Z servers.
Two-tier architectures. In this architecture, client directly interacts with the server. This type of architecture may have some security holes and performance problems. Internet Explorer and web server works on two-tier architecture. Here, security problems are resolved using Secure Socket Layer (SSL). The two-tier architecture is used to describe client or server systems, where the client requests resources and the server responds directly to the request using its own resources. This means that the server does not call on another application in order to provide part of the service. The two-tier is based on client-server architecture. The two-tier architecture is like client-server application. Direct communication takes place between client and server. There is no intermediate between client and server. Because of tight coupling, a two-tier application will run faster. Advantages: easy to maintain and modification is bit easy. Communication is faster. Disadvantages are: in two-tier architecture application, performance will be degraded upon increasing the user. Cost ineffective. Three-tier architectures. In this architecture, one more software sits in between client and server. This middle software is called middleware. Middleware are used to perform all the security checks and load balancing in case of heavy load. A middleware takes all requests from the client, and after doing required authentication, it passes that request to the server. Then server does not require processing and sends response back to the middleware. Finally, middleware passes this response back to the client. If one wants to implement three-tier architecture, then one can keep any middleware like WebLogic or WebSphere software in between the web server and web browser. In three-tier architecture, there is an intermediary level, meaning the architecture is generally split up between a client, that is the computer, which requests the resources equipped with a user interface, usually a web browser for presentation purposes. The application server, also called middleware, whose task it is to provide the requested resources but by calling another server. The data server, which provides the application server with the data it requires. Three-tier architecture typically comprises a presentation tier, a business or data access tier, and a data tier. Three layers in the three-tier architecture are client layer, business layer, and data layer. Number 1, client layer. It is also called as presentation layer, which contains UI part of our application. This layer is used for the design purpose, where data is presented to the user or input is taken from the user. For example, designing registration form, which contains text box, label, button, etc. Business layer. In this layer, all business logic like the validations of data, calculation, data insertion, etc. This acts as an interface between client layer and data access layer. This layer is also called the intermediary layer, helps to make communication faster between client and data layer. Data layer. In this layer, actual database comes in the picture. Data access layer contains methods to connect with database and to perform insert, update, delete, get data from database based on our input data. Advantages: high performance, lightweight, persistent object, scalability. Each tier can scale horizontally. Performance: because the presentation tier can cache requests, network utilization. Performance: because the presentation tier can cache requests, network utilization is minimized and the load is reduced on the application and data tiers. High degree of flexibility in deployment platform and configuration. Better reuse. Multi-tiered architecture. In three-tier architecture, each server performs a specialized task. A server can therefore use services from other servers in order to provide its own service. As a result, three-tier architecture is potentially an n-tiered architecture. Multi-tier architecture is a client-server architecture in which the presentation, the application processing, and the data management are logically separate processes. For example, an application that uses middleware to service data requests between a user and a database employs multi-tier architecture. The most widespread use of multi-tier architecture is a three-tier architecture. Entire application architecture provides a model for developers to create a flexible and reusable application. By breaking up an application into tiers, developers only have to modify or add a specific layer rather than have to rewrite the entire application over. There should be a presentation tier, a business or data access tier, and a data tier. Did you know The three-tier architecture concept emerged in the 1990s from observation of distributed systems. Enterprise software such as Enterprise Resource Planning, ERP, and Customer Relation Management, CRM, are unique because every business that uses them is different. ERP and CRM software must be custom tailored to the needs of each business. Traditionally, that has meant either custom developing an ERP or CRM system for the specific requirements of an organization, or purchasing an existing ERP and CRM system and customizing it. Both approaches have significant issues. Custom development projects often start innocuously. In software development, though, could be expensive and risky, and the majority of custom software development projects ultimately fail to meet the needs of the user. Compure ERP. Compure is a leading cloud-based open-source ERP software and customer relationship management CRM system. Compure solution provide businesses, government agencies, and non-profit organizations with easy, flexible, low-cost access to rich functionality for managing all financial distribution, sales, and service processes. With Compure, customers can easily and affordably customize a solution to fit their business requirements with no or minimal programming. Now, in the end, let us summarize what we have learned in this lecture. ERP solutions touch every aspect of a company, from warehousing to accounting. As such, a company's ERP solution should easily integrate with existing IT infrastructure components such as application servers, directory services, and storage arrays. Many large clients of enterprise commercial software are themselves not in the business of writing and maintaining software. They would rather rely on specialists and license the relevant technology from them. ERP does not provide an easy and inexpensive customization of the ERP software to fit the business model. In fact, in the 90s, when only commercial ERP solutions were available, many companies shied away from ERP because it did not fit into one of their processes in business. Client or server describe the relationship between two computer programs in which one program, the client, makes a service request from another program, the server which fulfills the request. Open source brings an alternative which addresses many of the key problems of both custom and commercial enterprise software. It begins by offering the user a freely available code base as a starting point.